All right, our next adventure is after levels of measurement are frequency distribution tables, and then we'll look at frequency graphs. So, frequency distribution. Definitions. It's the most basic way to look at a variable. It's frequency distribution shows the values that are taken on by a given variable. And then the third point I have here, it's all the actual data points you obtained for a given variable. So this is kind of the most basic thing you can do in statistics is take a given variable like, say, intelligence, IQ, and you apply the test to a number of people, and then you look at what's the pattern, what's the set of scores that you got. So some examples, if I asked a class of students how many hours they slept last night, and then the answers range, say, from 4 to 9, I could construct a frequency table where I would have in the first column here the different categories 4, 5, 6, 7, 8, 9, and then the frequency count for those. And remember, frequency is just a fancy word for count. So how many people slept 4 hours? 1. How many slept 5 hours? 3, etc. So quick review note, what level of measurement do we have with hours slept per night? Well, it would be ratio, because you would start off with 0 and count up from there. Remember, it doesn't have to be the case that anyone ever sleeps just 0 hours a night to say that it's a ratio. It just matters that the scale starts at a true 0. So an hour slept certainly does. Okay, so, and then these are the responses of what you observed, and then if you were to add up the number of times those responses occurred, that should equal the number of students that you had. So, in other words, we had 20 students, so at the end of the day, that should add up to 20 when we construct our frequency distribution. Okay, so some practice here. So, see if you can construct this this table here. You ask people how many books they read in the last month, and you get these different scores. 0, 1, 3, 2, 4, 5, 3, etc. So your table would look like this. We'd have a range of scores from 0 to 5, and then we indicate how many times the count that those different scores occurred. And you would notice that those would add up to 20 if you asked 20 people. Okay. Another concept is a relative frequency distribution. That's just a fancy way of saying percent, right? So how does this work? What percent of people fall in each category? Well, if 2 people fall in 0, and that's 2 out of a total of 20. Okay, so another example here of a frequency distribution. All right, so another example of a frequency distribution. Oops, wrong way. Let's say that you ask 25 people how many books they read in the last month. And then you have their responses here. So try to set up what that table would look like. You can hit the pause button for a second here to figure that out. Okay, so what it should look like is 0 to 5. 0 is the smallest number of books somebody read. 5 is the largest, and then how many times those occurred. And you should notice that they're going to add to 25, right? Because you had 25 people, the frequency count has to get up to 25. There's also this other idea that your book will talk about called relative frequency, where you determine what percent fall in these different categories. So check this out. If this is 2 out of 25 people, you would take 2 divided by 25, that's equal to 8. 3 divided by 25 people is going to equal 12. 5 divided by 20 is going to equal 20%, etc. And those percents, of course, should add up to 100%. So lots of times it's just easier to look at the data and not know the raw score, but say, okay, so 28% of people read 3 books, 20% of people read 2 books. Same basic thing. We just call that a relative frequency distribution. Okay. We can also do this thing called a class interval frequency distribution. And you notice what's different here. Instead of measuring out just how many reaction times I got that were exactly between 0 and 10, I lump all those together and count up 4. And I lump everything between 11 and 20, between 21 and 30, etc. The advantage of this is if you have scores that are spread out quite a bit, you don't have to list each individual score. You just list a range of scores and then the number that fell in to each one of those. So this, of course, between 0 and 10 would be the class interval we're talking about. And the question is, when would you use this? Well, if you had a large number of categories with just a few responses per category, it makes more sense to use this because it's easier to see a pattern. Is a crucial issue. So this, if we put it in graph form, which we'll get to here in a second, shows the kind of normal curve that we would typically like to see. And it's not just going to be a whole bunch of blips across a straight line, which is what you would get if you didn't group things. All right, so moving on, there's graphs that we can use to look at a frequency distribution. So let's say we just look at a group of students and say, what are your GPAs? It's one variable. We want to know what all the different scores on GPA are. Well, here's an example of what we would call a histogram. And these are both generated by SPSS, which we'll talk about in a moment. But a histogram has the possible values that somebody could score, the frequency count here, and the table, because they're on a continuum running from low to high, the columns you note touch. That means it's a quantitative variable that's continuous. And this line you can put on is the normal curve representation to let you check and see how close your pattern fits with what we'd expect in terms of a normal curve. And we'll get to the normal curve again in a second. Same data here. This time it's a line graph that we're getting, and oftentimes this will form a certain kind of, that's pretty ugly, but a certain kind of shape that we'd call a polygon. So line and polygon are the same thing. And then some examples would be GPA, SAT scores, reaction times, grades on the first test. These are all quantitative things that you could graph either with a histogram or a line graph. And then if you're dealing instead with qualitative data, something like gender, for example, you'll see that the chart looks very similar to a histogram, except there's a space in between to suggest that female is not really lower than male. The space suggests that you can move these categories around and you wouldn't really change anything. It's arbitrary which one you put first or last. That's a bar chart, and then you can also see there's a pie chart that we can make as well. Both of these show the same information, just artistic differences. So examples of qualitative data: gender, if you ask people what their favorite TV shows are, what residence hall they live in, etc. Okay, so to give you a little practice here on a histogram, how you would construct it by hand, which would be good to know. You start with the frequency table, and we have here the range of scores running from an A down to an F, and how many times each of those scores occurred. So how would you put that into a histogram? Well, you would start off on the x-axis with the range of scores that you observed, and then on the y-axis you would have the number of times those scores observed. So what would that look like? Oh, right, and then you would graph each column to represent the number of times that score occurred. So I did this on the computer, but if you did by hand, that's fine. You should have on the bottom here the different grades we would expect, and then the number of times those occurred. And you should note that's the same information that you got in the frequency table. Just it's a little easier to see as a graph. And your frequency graphs are something we'll do in SPSS, and you have instructions on how to do those in your SPSS guide using this data set that I made up. Okay, and then next we'll look at some examples of different graphs that were in some real research. All right, so here we're going to look at some different graphs and have you determine what kind of graph they are, and then I'll just do a little interpretation of each one. Some of these are from, I think most of these are from research article by Myers, who is well known for his intro psych textbook some of you might have used. And he's looking at the research on happiness, trying to show what kind of conclusions people have found across a number of studies. Okay, so the first question is, what kind of graph is this? And if you want to hit the pause button to think about it, and then I'll come back in and let you know, okay? All right, so this is a histogram. You will note you have quantitative variables or data down here. That is the extent of subjective well-being that someone expresses. And then over here we just have the frequency, the number of surveys that came in with those values. And you'll see, as we're going to talk about here in a second, this is a relatively normal curve. There are some slight deviations from it, but it's looking like most people, the central tendency here of the data are to come in about on 7 on a 10-point scale in terms of how happy they are. And then you have somebody clear down here. So either they were having a really bad day or maybe they misunderstood the instructions or whatnot. But you do have some extreme scores falling down here. So anyway, histogram is helpful to see the pattern of the data and seeing if it's generally normally distributed, which we'll talk about again just in a second. All right, and then here we have different kinds of marital status on the x-axis, and then the depression rate that you see for those different kinds of marital statuses. So hit pause for a second and try to figure out what kind of graph this is. All right, this would be a bar graph because down here you have the qualitative data. So, for example, divorced twice versus cohabitation versus divorced once, etc. And so, one thing that's interesting to see here is, though married people might report the lowest level of depression, never married people are pretty close. So, in other words, you might think about never married as being better off than those that have tried and it not worked out. And then, interestingly, cohabitation, which is becoming increasingly common, just if all of the things are assumed equal, which you can't necessarily assume that, but doesn't seem to offer the same protection against depression that marriage does. But I'd quickly have you think about whether or not there might be other things going on here. So, just for example, maybe it's that people that are poor have more strains and stresses that lead to more divorce, and so maybe it's not marital status per se that's fundamentally causing depression, but it may be a deeper underlying variable like poverty. Not saying that's the case, but you want to be careful about making those kind of causal assumptions. Okay, here's another graph. So look at it for a second and hit pause and try to figure out the kind of graph it is. All right, if you guessed or knew for sure that it's qualitative data down here, and that again you have a frequency distribution where you're looking at the percent that are very happy, what we would call the relative frequency, you're going to see that this is a bar graph because the data are qualitative. So we go here from less than a month to monthly to nearly weekly to several times in terms of folks' religious attendance. An interesting question it would be the level of measurement that this is producing. And I would say this would be a bad test question because it's a little complicated, but it's somewhere between ordinal and interval. So it's at least ordinal, is that as you go to the right here, we're getting more church attendance. But as you go from category to category, it's not necessarily clear that these are equal steps. But they look like it's pretty equal in terms of each step here being the same. So it's somewhere between ordinal and interval. Another interesting thing to think about here, this is self-report data, meaning they just ask people how often you go to church or go to religious services, and they're not actually measuring actual behavior. And they found that there's big differences between reported behavior and actual behavior in religious attendance. In other words, people tend to report, as you might suspect, a lot more attendance than actual behavior. So maybe there's more sleeping in on Sunday than people own up to. All right. So in other words, you might look at this graph and think about it as the extent to which people say they go to church or religious services. And my son here is talking about cookies he just put in the oven. Yum, yum, cookies. So I think that's relevant to happiness, talking about cookies. We're going to leave the calories aside for a moment. All right, so bottom line here is it's qualitative data. You got a bar graph, and it looks like as you go to religious services more, you have more happiness, but again, we can't make that causal attribution based on these kind of data. Okay. All right, here's another graph. Interesting. It shows the percent of people in each specific year from 1965 to 2000 that answered in a certain kind of way. And these are entering freshmen, people that are entering college for the first time, and they're answering whether or not it's very important or essential that these things be true. So I'm going to pause for a second here and have you hit pause and determine what kind of graph this is. All right, this is a line graph, a special kind of line graph where you have time on the bottom, but it's basically a line graph, or what you call a frequency polygon, and you're seeing what happens over time. So it's a little hard since the basic lines aren't in color, but let me just clarify here that the green arrows are pointing to the line that indicates people's endorsement of important to being very well off financially. And as you can see, that's increased over time. And on the other end, developing a meaningful philosophy of life has gone down drastically. So you can read this in at least one of two ways. One being that over time college students have become more concerned about finances relative to meaningful philosophy of life. That might be read as students becoming more materialistic, or our culture becoming more materialistic. But the other thing to think about, and I'm just trying to model for you here how to critically think about different kinds of data, but as you go from 65 to 2000, something changes in the makeup of college students, in that 65 much more likely to have just the financial and social elites of society going, whereas in the 2000s, I think you might have a broader cross-section of society attending college. So that could be accounting for the differences. In other words, we need to remember that it's not the same slice of society in 65 as it is in 2000. All right, another graph here. I'll have you hit pause and figure out what kind of graph this is. All right, welcome back. This is would be a type of bar graph. It's a relative frequency because it has the percentage here, and it's a little more specific than some of the other ones we've looked at because you're comparing men and women in terms of happiness. And you see that you have roughly the same pattern, in that you have the married being the happiest, the never married close second, and then the folks that are divorced or separated coming in even lower than that. So that is a type of bar graph that we're looking at. All right, and this one's a little more complicated. It's a combination of some things. I think I'm just showing it to you to help you understand the kind of way you can put data together creatively in a graph. So what we have here is from 56 to 98, several things it's mapping. One is the percentage of people that are very happy. You see that over here on this side, the right side. And then over here on the left side, it's the personal income in 1995 dollars. You'll see this a lot where they're holding it constant so that inflation doesn't make an impact. And if you want to stop for a second, try to figure out what story this graph is telling about the relationship between income and happiness. All right, well, my interpretation would be that if you're looking here, the percent of people that are very happy doesn't change a lot, even though the personal income is going up drastically. So you might have an increase in income that doesn't correspond to an increase in happiness. And there's a number of studies that have pointed this out, that once you get above a certain level of meeting your basic needs, that extra $1 million a year isn't really going to make a difference in your overall happiness. Another thing to keep in mind here, though, is that between 56 and 98, there's a huge change that's happened in the composition of the workforce, in that we've had a lot more women enter the workforce full time, some by choice, but also some by financial necessity. So even though you might have more personal income, it might mean that you have fewer hours within the family not sucked up by responsibilities at work. Okay, and then we're going to look at military expenditures per country. If you could stop for a second and think about what types of graphs would be appropriate, a bar graph would be appropriate, because you would have country as the variable on the x-axis as a qualitative variable, and then you're trying to determine the amount of dollars spent. So that would be a bar graph. So just for kicks, stop for a second, and I want you to try to figure out, like in billions, what do you think the U.S., China, Russia, and France spends? And draw a little graph that you would think. These are the top four. And when you're ready, go ahead and hit enter. Okay. So, oops, this surprises most people, and it depends on which year you look at the data and how they measure military expenditures, but this is suggesting these intervals are 100 billion. So this is 100, 200, 300, 400, 500, 600 billion. A little more than 600 billion the U.S. has spent. And these data, I should have this here, but it's pretty recent. It's like from 2007 on. U.S. is spending a huge amount relative to these other countries. And if you move on, you can see that is just a slice of the curve, and that most countries in the world are spending not even 1% of what we're spending. So a bar graph is one way you can tell that story. Another one is pie. And this one, it might be helpful if you think about it, in that it gets across one message that a lot of people may not realize, is that the U.S. actually spends more than the rest of the world combined on its military. So, right or wrong, 546,000. Note that, 546 billion is a lot larger than any of these other countries, even all these countries combined. And you think about it, depending on how you're trying to frame your argument, this is impressive in one way, but this also clearly conveys the percentages a little more clearly. Okay, so that's it for this. Next thing we'll talk about is experimental terminology.